So there's my tranexamic acid standard. Pretty concentrated, I don't need much of that one. And sometimes I just throw it on the floor. That's kind of getting thick. So I'm going to grab a different spotter for the tryptamine. So the tranexamic acid one is ready. And we can now use the tryptamine. This one I'll have to be a little bit more careful because it's in ethanol. Ethanol binds to the silica pretty well. So if I'm not careful, I tap it there initially, and then I want to wait for it to evaporate a little bit before I tap it again, so I don't get a spot that's wider than I want. I can put a little bit on the co-spot. What I want is I want to try to keep a fairly small diameter spot. The diameter of the spot after development is always going to be at least as large as the diameter of the spot before development. So if you let it get too big, sometimes you get what we call streaking, and it makes it hard to analyze. So that should be ready. And you'll see, if you look at this one, you should see a difference, right? The tryptamine itself is a little fluorescent. So instead of just being a dark background, you're actually seeing some purple glow where the tryptamine is fluorescing and giving back some violet, which is an interesting feature. So now I want to put these in their corresponding chamber. Being a little careful, I want to make sure that the plate doesn't touch the sides, because then it'll wick up between the side of the glass and the side of the plate and develop sideways. And then the tranexamic acid. You could use tweezers for this, but I find that I've got a little bit better dexterity just using my hand, and I trust myself not to touch the plate and get a fingerprint. So those are going to go ahead and develop, and while they are developing, I will put away my graduated cylinders. They should be dry, and I'm going to go fetch an iodine chamber, which is the stain we're going to use. Got an iodine visualizing jar. And this just has crystalline iodine pellets suspended in sand. And I'll just put the plate in there. I don't know if you can see, if I point it correctly. Right, it's kind of, a little bit dark inside. It prevents the iodine from subliming and getting all over the cap, because iodine solid sublimes readily. So we'll just submerge the plate underneath there so that the iodine can come into contact with the compound in the developing jar. So these are just going to develop. We're going to watch that solvent front, and we want that solvent front, which is now about halfway up the plate, to go to about the same distance from the top as the line that we drew is from the bottom, somewhere around maybe half an inch, something like that. And I can put the triethylamine away while I'm waiting. By now, hopefully the GCMS spec has done its job. When you're going to sketch one of these TLC plates in your notebook, you should basically kind of sketch out a rectangle about the same size as the TLC plate and then mark your spots. And then you're going to, from the top edge of the spot or from the center, if it's a really dark spot, you'll take the ratio to the front which is the number of millimeters the sample has moved, divided by the number of millimeters the solvent has moved, which is the distance between the line at the bottom and the line at the top that I'll mark when I take those plates out. And that's called the ratio to front. It's always between 0 and 1. Right? It's either not moving at all or it's moving exactly as far as the solvent front. You would like it to move somewhere between 0.3 and 0.7 for your RF in order to be kind of enough in the center of the plate to get a good, reliable analysis. And what we're hoping is to see, mostly one compound. But we already know that for the vanillin we're going to see some tranexamic acid, because we had a way over 100% recovery. At least that's the most likely impurity. To correctly label a TLC plate, right next to the plate, to its right, you need to put the adsorbent, which in this case will be silica gel, and the eluent, which is either the 1:1 ethyl acetate hexane mixture or the 1:9 methanol dichloromethane mixture with the added 5 drops of triethylamine, about 3 milliliters of solvent in each jar. And then the visualization method, we're going to use 2. We're going to look at it under UV light and circle the spots, and then we're going to put them in the iodine chamber to see if they'll actually stain with iodine as well. You can't look at them under UV light after they've stained because the iodine will impregnate the entire TLC plate and quench the fluorescence everywhere. So I'm going to open that up and see where we are. And we got a little bit to go. Somewhere like an inch, maybe an inch and a half from the front. So those are just developing. But I'm not going to go away now because I don't want to miss it. Can't calculate an RF value if you let the solvent front go off the top of the plate. The other thing I'm going to need to do is weigh the tryptamine beaker. So we might as well get that out while we're waiting. That way we can get a good percent yield of the dry. So here's our tryptamine, that pale yellow solid. Check that solvent front again. Yeah, it can still go. And we'll take the beaker over to the balance and weigh it while we're waiting for that. And so that vial is now, looks like it's stabilizing at 9.312 grams. 9.312 grams for the dry tryptamine in the beaker. Ordinarily, if you were doing the lab, you would put this now in a vial, but since no one else is using this hood, I'm just going to store the tryptamine in the desiccator until we're ready to use it next week to recrystallize and put it back. And we should now have our solvent front. So I'm going to pull that out and quickly, before it evaporates, mark the solvent front, which is just under the lettering. And trichloroacetic gas, or the tranexamic acid. And the tryptamine hasn't, yeah, the tryptamine has gone pretty much all the way to the top. Got that solvent front just a hair from the top. Dichloromethane develops a little bit more quickly. So I just want to wait, kind of wave that around, let the solvent evaporate. That one will stink because triethylamine smells like ass. All amines smell bad. That's why some of them have names like cadaverine and putrescine, which are 1,6 ethylene diamine and or 1,6 hexane diamine and 1,5 pentane diamine, respectively. Those are cadaverine and putrescine. Oops, already have that on. So we can discover that our vanillin standard is about halfway up the plate here. Got a nice circular spot. But then down here we've got like a little bit of a streaky spot. Sometimes carboxylic acids will streak. because they're in equilibrium with their anion form, and we didn't add any acid to keep it protonated, so we're getting a little bit of a streak. I think that's probably tranexamic acid, so I expect that's where I'll see my main spots. So we've got decent RFs for both of those two compounds for the vanillin. For the tranexamic acid, you'll notice there is actually a little bit of vanillin up here, and then these were spotted probably a little bit too concentrated. If I really wanted a good result, I'd want to redo this with much less compound. You see how big those spots are. That's an overspotted. We'll do another plate of that. But there's definitely a little bit of vanillin in there, not too much compared to the tranexamic acid. And then the tryptamine, right, looks like we've got another spot up here. Kind of hard to tell what that might be, since we didn't run either the vanillin or the tranexamic acid. And you'll notice that we are getting a little bit of sideways development, right? So it went in, you can see that section where the silica's kind of flaked off, so it developed a little crooked. And that's where the co-spot comes in. Right? These may look like they have different RF values, but that spot in the center is clearly just one spot, not two. So we got a little impurity. It's either the vanillin or the tranexamic acid, and then mostly tryptamine. So all of these worked to an extent, but the tranexamic acid is definitely too concentrated. So I can solve that problem by diluting them and by just putting less on. I'm just going to fill that vial up. And I'm also going to fill up my standard. Obviously that standard was made up a little bit too concentrated for TLC. Let's mix those around a little bit. And we'll grab a new plate. See if we can get a slightly better result. Here's my isolate and my co-spot and my standard. This is TCA 2. It's the second version. And I'll choose a nice thin spotter so I can get a really small amount of sample on there. Put that in. So instead of spotting multiple times, I'm just going to spot once. One quick tap, one quick tap, that should be enough. And then the standard, same thing. One quick tap, one quick tap. Toss that on the floor. And we can sit that in its chamber and let that develop. So I've marked these spots so I'll be able to see where they were by UV after I stain them. And while we're waiting for that to develop, we will stain these guys by just dropping them in there. We can put all three in there at the same time. And we will just shake that jar around until they're well and truly submerged in the sand. I can rotate that a few times and just let that sit so those can develop. Since these two worked, I don't need these anymore. I don't need my methanol and dichloromethane. I can put those back. Get rid of these two pipettes. Some Because there was nothing in there except solvent. I'm just going to put those back. No need to clean the Erlenmeyer flasks, because again they had nothing in them but solvent. Same with this one. There's the ethanol. Oops, dichloromethane. I am going to use tweezers to take them out of the jar, because I don't want to stain my hands with iodine. Sit a little longer. So these two I'm through with. I actually don't need this solvent anymore either. Those can just evaporate in the back of the hood. Watch glass back. That's about 2/3 of the way up. And I'm pretty sure I'm going to be done with these as well. Should have been long enough in the iodine jar, I believe.